And we are now moving to the next presentation, which is a focus demo by Cedric Foellmi from F52 Technologies. And Cedric is going to present Arcsecond.io.
I'm very happy to participate to this conference. Thanks very much to the organizer to allow me to present Arcsecond.io. It will be a demo, and I hope to not experience the demo effect, but it should be okay. Arcsecond.io is a project. It started with as a personal project, and now it's a fairly extended online platform for astronomical observations. I removed the citizen science description of it because compared to the last talk, just the previous talk, Arcsecond.io is not a collective effort of citizen science. It's mostly a platform that can be used by a lot of other people everywhere. But I will describe everything. Just a quick presentation. I used to be a real astronomer. In the past, I've been doing astronomical observations in various countries, Switzerland, Canada, Chile, and France. I spent a lot of time in Chile, especially in La Silla Observatory, where I spent more than 360 nights. And since 2010, I switched to a private sector and work as software developer in various startups and companies. And today I'm a vice president engineering in Azeta Nanographics. And all these years as astronomer taught me a lot of things about software. And then I switched to the private sector, and I realized how much I was still needed to learn to be a real professional software developer. And I enjoyed it a lot. So my professional specialization is actually software industrialization and engineering. So I help team to deliver software in an industrial way. A little bit of history for Arcsecond.io. It all started in 2003 with Mac OS, or at that time it was called OS X Tiger widgets. It started very small with tiny widgets like that, providing just the basic times values. But in 2010, these widgets were transformed into a real native macOS app called iObserve. Of course, the very first version of iObserve was not that sophisticated, as you can see in the screen, but this is the current version of iObserve. I hope to have some of the iObserve users in the audience. I can see you. But iObserve was, again, a personal project. It's still available in my App Store. And the main idea is simple. It's the app I wish I had when I was at the telescope. So it's nothing really revolutionary. It's a lot more software engineering than actually algorithm or mathematical difficulties. But the main thing is that it's all at the same place, and it helps you prepare observations. But iObserve is what we call a heavy client. So everything is inside this app, all the connectors, all the transformations, all the storage and everything is handled in this heavy client. So it has some advantages and it has disadvantages. Once upon a time, there were an iPad version too, but that's another story. Arcsecond.io is the direct and much extended evolution of iObserve. So that's it. And the main goal was to bring this particular view with air mass curves to the web, because that was the main pitch at the very beginning. Because it was limited to macOS users, and even if I know that there are many Mac users in the astronomer community. Still, there are many others. So I wanted to bring this to the web. A little bit, oops. Point on a different philosophy, the Apple versus Unix philosophy. Arcsecond Io is clearly designed with more the Apple philosophy, in the sense that we recognize the value of the integration. That was the philosophy of iObserve too. I love also the Unix philosophy, which is do only one thing and do it well. That's not really the case for Arcsecond Io, which I think brings a lot of value because it is all at the same place. But of course, it's a bit difficult because there are many things to do. But I will let you judge the quality of the results. But that's the philosophy behind Arcsecond Io and iObserve. Just a quick slide to explain a bit. Arcsecond Io is actually a software system. It's a bit more than just a software. And I emphasize a bit this part of software system because actually that's make things a bit more complex. But it's actually very, very interesting, and I enjoyed it a lot to build this. And actually, it's my best business card in the software world. So the main 2 points of Arcsecond Io is from one side API.arcsecond.io, and the other side is www.arcsecond.io. The first one is the data. It's a pure REST backend. I am rather strict on applying the REST principles because I've seen many REST APIs sometimes in various astronomer website, but REST is not just making JSON. And so API.arcsecond.io has more than 100 endpoints. It's built with Django 3, Django REST framework. It's all Python with thanks to being written in Python. I can easily plug very important and community-powered libraries like AstroPy. I use a little bit of AstroPy, not much, but still there are very useful things. AstroPy, Celery, Postgres, the usual, I would say, standard Python backend stack. We use Amazon S3 for storage, and of course Unicorn, UVcorn for the server. Its internal architecture is what I call a microlith. There's a lot of fuss and a lot of discussions about making a monolith versus microservice in a cloud software world. But I think a monolith which is well decoupled can be called a microlith and enjoy the advantages of small modules, but the easiness of deployment of a monolith. So it's a microlith. It's deployed on Heroku, which is a PaaS on top of Amazon. Amazon is a IaaS, infrastructure as a service. Heroku is a PaaS, platform as a service. It provides many high-level services and makes things a lot easier. And basically, it let me concentrate on development and not the operations. And I will speed up a little bit because otherwise we won't have time for a demo. So that's really the main foundation. API.arcsecond.io is the main thing on which I can build other stuff. And the main usage of API.arcsecond.io is www.arcsecond.io, which is a single page application written in Vue.js and using also libraries and astronomical algorithms, which are all open source. It's also deployed on Heroku and everything. But of course, that's not the only possibility to use api.arcsecond.io, which can be used by anyone in different ways. It's opened. Some endpoints are private, some endpoints are public, but it's here, there to be used. I've written also a Python CLI, which is can be used as a command line interface. I will show you, and also a Python module. And last but not least, AuthCloud, which is the simplest tool that can be used to upload data to Arcsecond.io. I will show you how it is used by observatories. Will be used by observatories. Just a quick thing, the only way to build such a software system is really to industrialize everything. So it means that software quality has top requirement. It means unit test, unit test, unit test, unit test. So a lot of unit tests everywhere, as many as you can. Also integration tests and everything automatic. It must be automatic linting, automatic testing, automatic code quality, security checks, automatic deployments. I mean, that's the only way to reliably produce software in a cloud and otherwise to make sure that you can sleep well and not worry about bugs. Because when it's online 20 hours a day, 7 days a week, and you have another job, it's important to be relaxed and know that it works. And then, of course, monitoring as well when it's online. So a demo. You can try yourself www.arcsecond.io. Of course, you're free to try. Arcsecond.io has a public and free part, and of course, private part. It's a commitment to have always a free and public part that can be used by everyone. It's actually already used in some classrooms. I'm very happy with that. So we'll, of course, keep a useful part of Arcsecond.io as a free part. But of course, there are some paid services because we want it's a real service with real servers, and it's all funded personally for now. So that's it. Let's move. I hope you can see my screen. Let me know if it doesn't work.
We see your screen. Yeah.
Okay, wonderful. I will reduce a bit. Okay, that's it. So that's actually my account. It's Arcsecond.io. This is how it appears. So you can see that there is quite a few things already built. And let's start with iObserve. So iObserve, you can try, you can actually choose any place on Earth to use iObserve. You can use also there is a built-in observing site encyclopedia inside Arcsecond.io. So let's choose, say, LaCIA and open iObserve. That's it. So that's iObserve. I mean, that's the macOS app basically rebuilt on the web, as you can see. So you have air mass curves with tracking. You can choose, of course, the date you want, and you have star tracks. You can follow star tracks along the night. Okay. You have. I should have opened. Actually, I should have chosen. Zero panel. Yes, choose panel. That's it. To show you that there are also horizon masks in some observatories. So if you choose UT1, for example, I mean, there is a list of horizon masks which can hide part of the sky. Oops, there is a little, yeah, you're right. So you can see that depending on your targets, yeah, it can be hidden by some of, I know that the J6, I think is very, yeah, the J6 is probably the worst. There's a little glitch of drawing. You can see that you have the shadow of various observatory domes. We are on the plateau of Cerro Parnal, so it can have an impact on your observations. Of course, there are many customization possible to just see what you want. You can choose multiple curves. You can change, of course, the colors. That's all the iObserve classical. Oops. Classic. Little bug. It's supposed to disappear. Okay. This stuff is supposed to disappear. I've made an update recently, and okay, because I rewrote all these components, of course. But okay, that's the demo effect. Of course, there's a little thing, but that's the idea. What I wanted to show you is also that you can actually we'll leave this with this small thing. Wait, I want. Oops, no, I wanted to show this. Yeah, and you can show the Starlink tracks. So it takes a bit, yeah, of time to be computed and show off. Yes, no. I would be surprised to not have any Startrack links on that day. Of course, that's the demo effect. It was working yesterday. Okay, I will fix this. You have normally up to 2 seconds to drawing of Startrack links across the sky. I'm a bit disappointed, of course. Not showing. Strange. Okay, I can see it's difficult. You can see there's still a little UI glitches. Of course, JavaScript is not as easy language as Objective-C. You have access to Aladdin and publications related to these objects. Of course, you can import objects by coordinates manually or import from files. So you can provide actually a list of targets. It will import. You can import exoplanets from the whole exoplanet.io catalog, and as well as target lists. Target lists are things that can be shared and can be private or public. For example, we provide the Messier catalog target list. This is the whole Messier catalog with 110 targets. So if you want to prepare iObserve and use this target list to say to make a Messier hackathon, for example, then you can use this target list. So that's the main iObserve. That's the main Pro tool. That's our section of Pro tools. iObserve is the flagship Pro tool we have, but there are some others like Transit Finder. Sorry. So it's built on the list of exoplanets which have transits. So the idea is to be able to predict and predict when exactly a transit will occur and in what conditions. So here we are in the last year observatory. We choose 55 CNCE. So you know that the transit is in 10 or 20 minutes. Yeah, 18 minutes and 57 seconds. So you have the various information about this, and you can filter in various way the transits. We make sure that every time you choose another transit, the URL change. That helps actually make a bookmark or share a URL of specific transit to be shared, and you end up right away into the right page and configuration. So that's another pro tool. We have a Standard Star Explorer, Standard Star catalogs.
You have about 5 minutes.
Okay. Thanks. Standard Star's catalogs have been spread around in many different websites, and often in bad formats. Astronomers tend to create web pages, but web pages are not easily consumable by machines. They are easily consumable by humans, but sometimes catalogs must be used by machines. And of course, you have many catalogs in the CDS in Strasbourg, but the Standard Star was different. So we actually open sourced and took all these catalogs and made available in a consistent way in GitHub. It's all open source. You can fix and correct and see and everything. There are all the origins where all these data come from and can be used here. So you can put coordinates or star, whatever, and it finds you the standard stars, the closest standard stars to this object in all the catalogs. Okay, so that's another pro tool. We have yearly visibility. So the idea is to see the visibility of, say, a target somewhere. You can choose where, and somewhere on Earth. So you have the January on top, December on the bottom. So you can see the length of the night changing and the visibility depending on the threshold of altitude you can choose here. That's another pro tool. Times converter, distance converter. That's the thing of iObserve which have been improved, rewritten in a modern way with open source algorithms. It's all available on GitHub, and there are more things than in iObserve. And we have of course, the Observe Insights encyclopedia, which is necessary to work. We have telescopes, satellites. I want to show you also the activity screens because we monitor. Okay. Yeah, live map. We monitor great observatories, what they observe, and we scan this and provide activities. We call this activities because it's observing activities. So we scan ESO, Gemini, HST, and Swift satellites for now. We intend to provide to scan more stuff later on, but that's the idea. And you can actually subscribe to these activities. For example, if you take the Mauna Kea Observatory, that's the page of the Mauna Kea Observatory. You can see that you have the map, the various telescopes, and the activities, which is the various things. So you can see that we detect the activities, the people, the program, the instrument, everything has been normalized, so it can be easily accessed and linked. And funny stuff, you can actually, this way, you can actually create your own activities. It's designed to be an alert system that can be used by small observatories actually to create activities and publish activities that can be then subscribed on by other people. So let's say we create real demo test So then, using the Arcsecond Io Python module, we create an activities for the telescope in a Mauna Kea. So trust me, that's the UID of the Mauna Kea. And it takes just a bit of time to appear here. Unfortunately, I don't think we have enough time. I hope it will appear. But just to show you how it works, and the thing is that I personally subscribed to the activities of Gemini North in Mauna Kea, so I received a mail. Yeah, so you see that an observation is running with Gemini North, published by Cedric just less than 10 seconds ago, and you have an activity page you can actually open. Oops, it will open somewhere else. That's it. It will open Safari, etc. So you have a page with the activities. Yes, real demo test. That's it. And last but not least, I will finish with that. We have portals for small observatories. And I don't have time to show you, but we have a space for collaborations for small groups of astronomers to share data, to share target lists, to share night logs. We are preparing night logs. This is, for example, dataset tables of an observatories that we work with in Chile. So they are uploading their data to their own portal. You can see that they have their own subdomain. So that's something the main idea behind all this is to bring observations to the cloud. That's it. So we want to help small observatories. We know the big ones have their own stuff. We want to help small observatories to bring their observations to the cloud with the benefit of having something professionally developed and supported with modern tools. And that's it. If I have 1 second, I will just show you.
Just 1 second yet.
1 second to show you the collaborations. We have a collaboration space here where you can share. Yeah, that's a collaboration. You can share target lists, data sets, and night logs. And this is a space designed for small collaborations to help them prepare observations. Often I've seen various people working for the same projects. It's not always easy to share what they observe, how they observe, and to share the data. Here, you can share data. It's stored on Amazon. It's cheaper than Dropbox, at least for sharing. And because the storage is paid only once, and we prepare night logs also to be shared soon live. That's it. I will stop here. There are too many things to show.
Okay, thank you very much, Cedric. Thank you very much. And so thank you. We have a question from Danuta Sosnowska, and that's about what about the confidentiality if you upload your data about your observed object? What about the confidentiality of the data and about the security of the data? I think the security is answered on your website. I was checking, but maybe please you can answer on both confidentiality and security.
Yes. Your data is always yours. Your data is stored on Amazon on private buckets, encrypted, private by default, with all the switched privacy and security on. It's very safe because it's Amazon S3, which is basically half of the internet. As for the access of this data, it's going only through Arcsecond. You cannot access your data otherwise. And every user has his own slot. Actually, you cannot access the data. It's very much organized, and Otherwise, everything is encrypted. Of course, we have professional certificates. All the communications are encrypted, even between the CLI and the Python module and the backend. As soon as we can, we intend to pay for various pen tests, what we call, to validate. For the moment, Arcsecond.io doesn't have enough resources to actually certify the security of the data as real companies does, but we hope to make it as soon as we can to certify the security of the data and the system by external sources. But this, otherwise, we have taken everything that we can to secure the data so far. I hope to have answered.
Thank you very much.